So far in this course, we've been learning about how to query our database, how to write select statements to pull data out of our database, and to perform calculations. It's time to change gears though, because there's more to SQL than just querying. In this chapter, we're going to be learning about writing SQL statements to create tables. We'll be creating tables, altering them after we've defined them to add or remove columns, and then deleting those tables. We'll be looking at how we can set the schema that the table resides in, and then we'll be doing a deep dive into the different types of constraints that we can put on that table, how to create primary keys, foreign keys, check, unique, and not null constraints. So there's more to SQL than just querying. So far, we've just been using the select clause, but you could categorize the different kind of statements that make up SQL into a few different buckets. There's DDL, which stands for Data Definition Language, which is concerned with the create, alter, and drop clauses. That's what we're going to be looking at in this video right now. There's the data manipulation parts of the language, concerning insert, update, delete, and select of course as well, which is what we've been using so far. The DML statements are the ones that we use to insert, update, or delete data from our database, and we're going to be looking at those in the next chapter. The DCL part of the language deals with permissions, and so it has statements like grant and revoke, for granting and revoking permissions. And finally, there's a part of the language called TCL, Transaction Control Language, which has clauses like begin, commit, rollback, and many more, to manage how the database deals with transactions. So far, we've primarily focused on DML and the select clause, and in the next two chapters, we're going to be fleshing out our coverage of the DML and DDL parts of SQL. We won't really be covering the data control or transaction parts of the language in this course. They're really beyond the scope of it. And also, I would say most of the complexity of SQL really resides in using the select statement, which is where we've spent all of our time so far. So let's turn our attention now to creating tables. And when it comes to table creation, the first part is designing the tables, where you go through that process of identifying the entities that you want to model in the database, the attributes of each of those entities, the relationships between those entities, and that whole process of normalization. But full table design is also beyond the scope of this course for now. So in the coming few videos, we'll instead be focusing more on the syntax and the practice of table creation, not the design of good tables, which is quite an extensive subject. Though of course, we will be touching on here and there what good table design looks like. Casting your mind back to the beginning of this course, you would remember when we touched on the relational model that each table should contain attributes that describe a single entity. So at its most basic, a table definition consists of a collection of attributes that describe the entity, their data types, and the definitions for any additional constraints like primary keys, foreign keys, or other types of constraints. And the basic syntax for table creation in SQL matches that. It starts with the create table command, followed by the table name, and then a list of the different columns or attributes in your table and their types. You can specify constraints in line with the column itself, and they're called column constraints, or you can specify the constraints afterwards. And when you do that, they're called table constraints. But I'll go into that more in the next video. On the topic of table and column names, my preferred approach is to use what's called snake case, which is also what you'll find used in the official Postgres documentation. With snake case, you use underscore to split words, and you always use lowercase. So in this example here, table underscore name, column 1 underscore name, column 2 underscore name, and so on. And when it comes to naming tables, my personal preference is to use pluralized names. So if you have a table that would store users, I would call that table users, not user. Let's do a quick refresher on the different data types that you can use for columns. There's character types, char and varchar, there's numbers, integers, and also the fixed and floating point types, numeric, real, and double precision. There's the date and time types, date, time, timestamp, and interval. There's a Boolean type, there's a binary type, and there's a whole lot of other different data types as well that have more specific use cases. Let's jump over to our code and put all this theory into practice. In this and the next few videos, we're going to set up a couple of simple tables to model the idea of users who can store notes in a database. We've got the basic syntax here. Let's comment that out for a moment. And now let's go ahead and write a create table statement to create our table, which we're going to call users. What are the different attributes that we want to store for each user? Well, let's store their first name. And we'll use varchar. We can specify a limit to the maximum number of characters that can be stored. For first name, let's set that to 100. I think that's a reasonable limit. Let's also store the last name for each user. Also a varchar. Let's imagine that for each user, we also would like to store their email address. Again, let's make that a varchar. We'll set that to 100 too. I think that's a reasonable length. And finally, for each user, we'll also store their date of birth. The date of birth can just be of the date type. There's no need to store any time component. We only need the date. We can now run this create statement, and we don't see any errors. We can go over here to our database navigator and have a look for that table that we've just created now as well. It's going to reside in the public schema. Click on public, and then just select refresh. We scroll down, we can now see our users table that we've just created. You could expand that even further as well and check that the columns were as you specified, and that looks correct. So this table was created in the public schema, which is currently the default schema. Notice as well that the table does not have any constraints at this point, doesn't have a primary key, for example, so it's not conforming to the relational model. That's fine though, we'll continue to improve this table definition coming up. Notice as well that if you actually tried to run this create statement again, you'd get an error. And that's because the table already exists. If you were writing a script though, which you just wanted to be able to run, and skip over creating the table if it already had been created, you could come up here and you can write in if not exists. Now the users table will only be created if it doesn't currently exist. So you could run this, nothing actually happened because the users table already exists, but this time at least you don't get an error. I'll go ahead now and just put some data in this table. We'll cover inserting, updating, and deleting data in much more detail coming up, but it will help me to illustrate a few things just to show you a basic data insertion now. I'll insert myself into this table. So I'll just insert now one row, which is my own details. If you have any questions about this course, by the way, don't hesitate to email me at that email address. And my birthday is the 4th of October, 1984. Let's run this statement. The statistics down the bottom says that we've updated one row. Now let's write a select statement just to pull that data back. Great, that looks fine. Quite often you'll come across situations as well where the tables already exist, but you may want to add or remove particular columns after the table has already been defined. Now let's have a look at how we could add an additional column to this users table. We start with alter table users. And then after writing this, you specify what modification you want to make to the table. In our case, what we're going to be doing is adding a new column called isActive, which is of Boolean type, and we're going to be using isActive to store whether the user is active within our system. To do that, you write add, and then the column name, and then specify the type. Let's run that statement. Now let's run that select statement again against the users table, just to ensure that that change occurred correctly. In dbeaver, you can do this by just selecting the query that you want to run, and on Windows, just using that keyboard shortcut which is Control-Enter, or by pressing that icon in the top left corner, execute SQL statement. If you've got some statement selected in dbeaver, then it's just going to run that statement alone. Running that, we can see that our new column isActive has been correctly added. It's got the value of null though, rather than true or false. In a coming video, I'll show you how you can specify a default value for a column. So if the column is added to the table, or if a new row is inserted in that table, there's a way that you can specify what the default value that will be used is. Similarly, you can also use this alter table statement to remove columns. Let's say that we wanted to remove the date of birth column. It turns out it just isn't getting used much in our database. So again, what we would do is start with alter table users, because we want to alter the users table. And this time, rather than adding a column, we actually want to remove a column. To do that, we use the drop keyword. So we'll write drop date of birth. Let's run that. Now let's come back up again and let's run that select clause again against the users table. And our date of birth column is now gone. Not only was the column removed, but of course any data that resided within that column is now permanently deleted from the database as well. Finally, if we wanted to completely remove a table from the database and all the data within that table, we can use the drop table command. Let's drop the users table now. When we run this, the users table and all the data within that table will be completely deleted. If you try to select now from the users table, for example, you'll get an error. And that error says the relation users does not exist. That's expected. And we can also come up to the database navigator. If you refresh this public schema, you'll find now that the users table is gone from the list. When we created the users table, where it ended up was in the public schema. We touched on schemas earlier. Schemas are part of the ANSI SQL standard, and most database objects belong inside a schema. When you create a new database, Postgres automatically creates a schema called public, and then tables live within that schema. If you have just a couple of tables in your database, then using the public schema is probably fine. But when you start to get into the tens and hundreds of tables, it's often a good idea to organize your tables into different schemas. How could we create a new schema and put our users table into that schema? You create a schema simply by saying create schema, and then name it. Let's call our schema playground. Run that command, and we now have a new schema. Now how can we create a new table in the playground schema? Well, we can simply prepend it to the table name. We run this command, we've now created a new table called users inside the playground schema. Let's check it out in our database navigator. We'll refresh the list of schemas, and there it is. We can see our playground schema. Inside that schema, which can hold more than tables, it can also hold views, indexes, functions, and so on, we'll find that there's our single users table. And so now for each of these different commands, whether we're inserting, selecting, or altering the table, we now have to fully qualify that table name with the playground schema. So we can insert a record into that table, we can select from that table, and so on. If you don't want to have to fully qualify the table name with the schema every time you work with it, you can update what's called the search path, which is what Postgres will use to fully resolve a table. We won't worry about getting into that here though. We'll always just explicitly list out the schema. We'll now finish this video by cleaning up our environment and returning it to how it was before we started this video. So what we want to do is delete our playground schema and any tables or other objects that reside within that schema. To do that, we can come down here and let's write drop schema and specify the schema name, which is playground. You also will want to provide one more option though, and that's cascade. And what cascade will do is ensure that not just the schema, but anything that resides within that schema is also deleted. So any tables, views, functions, indexes, sequences, data types, and so on. Let's run that command. And now let's come over to the database navigator. Let's refresh that list of schemas, and we can now see that our playground schema has been deleted. So our environment is now back to how it was before we started this video. In the next video, we'll look at how we can improve the definition of our users table to include a primary key, and we'll also create a table to store our notes that users create, and we'll make sure that we also set an appropriate primary key for that table.